Hi everyone, I'd like to welcome you to Mr. Q Does Math, the video show where Mr. Q, that's me, does math problems. Hey guys, so today we're going to be simplifying rational expressions, and one thing I want you to remember is the difference between an expression and an equation is that an expression is going to have no equal sign and an equation will have an equal sign. So when we're simplifying expressions, we're basically trying to find what things can we cancel off to simplify and make this complex expression here a little less complex. So with this one, you want to start off by, we have A's in the numerator, B's in the numerator, C's in the numerator, and A's, B's, and C's in the denominator. So hopefully by doing some operational math, we'll be able to get rid of some of these and cancel some of these off. So the first thing I see is these parentheses, so I want to get rid of those, and the way we do that is if we have an exponent here and we're raising these exponents to this power, what we do is multiply. So we multiply -1 times 3, 2 times 3, and this is a 1 here, even though there's no actual number 1 here, it's just implied that there's a 1 here, so 1 times 3. And so let's rewrite our problem. So the numerator will stay exactly the same. So it'll still be 3a squared b cubed c to the -2 power over -1 times 3 for a is going to be -3. 2 times 3 is 6, so b will have a 6. And 1 times 3 is 3, so c will have a 3. Once we've rewritten the problem, we move on to what else we can simplify. So I don't like these negative exponents, and we should be able to simplify that. You don't want negative exponents in your answer if possible. So we'll try to get rid of them. And the way that we do this is by pretty much using the inverses of the exponents and then just basically adding or subtracting them depending on where they're going. So just remember, if we have something like a to the -1 power, we can simply rewrite that as 1 over a to the first power. Okay, and the good thing about that is that we can also go both ways. So if we had a -1 down here, we could simply make it positive by bringing it up to the numerator. Okay, so let's apply that principle over here. So we've got, on our a, we've got -3 down here. Let's bring those 3 to the top to make it positive. So in our new rewritten expression, we'll have these 3 a's that are negative brought up here, so we'll have 3 plus 2, so we'll have, our 3 will still be the same. We'll have 5 a's because of what we added here, and then this will be gone. The b's are both positive, so those will stay the same. And we've got -2 exponent here, so we'll bring that down to make it positive, and there's already 3, so we have to add, so that'll be 3 plus 2. Just make sure, so this will still be here. We have a B3, and put this in. We'll have our B6 down here. And so we have our -2, we wanted to make it positive, so we bring it to the bottom, so we have to add the exponents. So that'll be 3 plus 2, which is c to the 5th. And now I still have b's in the numerator and b's in the denominator, so I want to see how much of that I can simplify. So let's just look at this one piece, our b piece of our expression. What this piece is basically saying is that we have b times b times b in the numerator, and the denominator we have b times b times b times b times b times b. Okay, and that is the equivalent of b cubed over b to the 6th. So now we cancel what terms are in common. So there's 1 set, 2 set, 3 sets, and we're still left with b times b times b in the denominator, so that'll be b cubed. And so over here, we've gotten rid of all these because we canceled them, and we've gotten rid of 3 of these, so we're left with b cubed, and now we can rewrite as 3a to the 5th, no b's anymore because they canceled, over b cubed c to the 5th. Now, the 3 can't be canceled with anything. We have only a's in the numerator. In the denominator, we have only b's and c's. So that means this has been fully simplified. Another type of problem that you'll see is something that looks like this. It'll ask you to evaluate, and there'll be a bunch of different terms, and you'll have to multiply. So the first thing I want you to look at is that they want you to multiply, but don't do that first. Another type of problem that you'll see is something that looks like this. It'll ask you to evaluate, and there'll be a bunch of different terms, and you'll have to multiply. So the first thing I want you to look at is that they want you to multiply, but don't do that first. Okay, when we're simplifying rational equations, you have to an equation has an equal sign and this doesn't have an equal sign, so this is an expression. When we're simplifying rational expressions, we definitely want to try to simplify first so that hopefully things will cancel. Your goal in this unit, in this chapter, is to cancel. So to cancel, I would just start by breaking this problem up into 4 distinct pieces. 1, 2, 3, and 4. And I would almost work this as 4 separate problems in the beginning. So let's work with the first part. We have x squared plus 4x. We're going to factor this because we can see that there's an x here and an x here. So they have the x in common, so we can pull out one x. Put our open parenthesis. So to get x squared, we'd have to multiply by another x here. And there's already an x here, so all we need to do is add 4. So that's piece 1 completed. Now let's work on step 2. This guy. So x squared minus 9 is actually one of the special factored values that you can get. Basically, it's a quadratic, but there's no b term. So there's no term that just has the regular x by it. So basically we're looking for 2 values that will cancel out when you multiply them by foiling. So we know that since this is a negative 9, one of our numbers is going to have to be positive, and one of them is going to have to be negative. So we can put a plus and a minus. And because these cancel and there's no b term, we know that the value here must be the same. So this is still going to be x and x to give you our x squared over here. And this is one of the perfect squares, so a difference of squares formula here. And so we can just factor this into what times itself will give us 9, negative 9, and that'll be positive 3 times negative 3. So that works out the second piece. Now we move on to the third piece. This is x plus 3. I don't see, this is an x term here and a 3 here. I can't cancel anything, so I'm just going to leave this as it is. And then I'll move on to step 4, which is factoring this piece right here. This is telling us that we have 2 numbers that multiply to negative 12 and add to positive 1. So you guys should be pretty familiar with factoring already. The factors are, I would say, 3 and 4, and we'd need to subtract by 3 and add 4, so that we would have a positive 1 and multiply to negative 12. So we have our x plus 4 and x minus 3. And if you're ever unsure about your factoring, remember we can just FOIL and multiply it out and it should work. I'm not going to do that in this video. I have other videos up on factoring, so if you need to review that, please check those out. But now that we've done all that, we've factored all these pieces, let's see what we can get to cancel, if anything. So first, you can check top to bottom, or you can check cross products right away. That's basically up to you. So I like to check the diagonals first. So let's see, on this diagonal we have an x plus 3 over here and an x plus 3 over here. So these are going to cancel. And just remember to put a 1 here, because when you cancel something it doesn't just disappear, it just becomes a 1. So that quantity is canceled and it just becomes a 1. Now we have an x plus 4 over here and an x plus 4 down here, so we can cancel those. Now nothing else is left on the diagonals to cancel, but over here we have an x minus 3 and an x minus 3, so those can cancel. These are 1s. And it looks like everything canceled except for this lonely x right here. So now we do the multiplication. So x times 1 is just going to be x, times 1 across here is just going to be x. And 1 times 1 is 1, times 1 is 1, x over 1. And we know that x over 1 is just equal to x. And so that's the solution for that problem. With these, just remember, you're trying to simplify, so factor first, then see what cancels, and you should be fine.